Namaste everyone, welcome to Vidya Lakshmi School YouTube channel. Myself Moses, chemistry teacher here. In the previous video, I have started 15th group elements, that is nitrogen family, and we have also discussed certain trends in the family over there and physical properties also we have discussed. Okay, in this video I am going to discuss some of the chemical properties of group 15th elements. Okay, group 15th element. The first thing is oxidation state. Okay, first one is oxidation state. When it comes to 15th group elements, right, the general electronic configuration of 15th group elements are going to be NS2 and NP3, okay. Actually, when it forms bonds with metals or non-metals, right, okay, with non-metals or whatever, okay, if the element whichever it is going to be bonded over there with low electronegativity than that of nitrogen or any one of these 15th group elements, right, by gaining what I can say, when it forms 3 bonds with low electronegative elements, right, then it can possess -3 oxidation states. Okay, by utilizing what I can say d orbitals also, right, it can form 5 bonds over there. With more electronegative atom, it can form +5 oxidation state. Okay, and we can also consider what is this one, -3 and +5 over there, and +3 oxidation state also we can consider with more electronegative atom over there. Okay, by which we can get 3 oxidation states over there. One is -3, one is +3, one is +5 over there. Okay, now the minimum oxidation state is -3, the maximum oxidation state is +5. Maximum oxidation state is +5. Okay, we have many other oxidation states by which we can see in the case of group 15th elements over there, but majorly we will be seeing -3, +3 and +5 in common. Okay, now we have seen what are the oxidation states are possible with group 15th elements over here. Now when it comes to -3 oxidation state, right, as we go down the group, tendency to show or exhibit -3 oxidation state decreases. Tendency to show or exhibit the -3 oxidation state decreases. It is the reason for like showing less tendency towards -3 oxidation state as we go down the group is, it is because of, as we go down the group what happens, down the group metallic nature increases. Metallic nature increases because of this particular reason, right. As metallic nature increases from top to bottom, electropositivity increases, electronegativity decreases, right. As electropositivity increases, instead of showing -3, they can show any one of the positive oxidation states, right. That's what, as we go down the group, what happens is that -3 oxidation state decreases. -3 oxidation state decreases. And let us see the another point here. Okay, the stability of +5 oxidation state decreases down the group. Why it is so? Okay, to show +5 oxidation state, right, in most of the times what happens is that if you take the pentahalides, what has to be done is that the ns orbital should get excited and the paired should become unpaired, and it becomes what, ND1 over there. Okay, it starts from third shell over there, means from phosphorus it starts over there. Okay, now to show +5 oxidation state in most of the cases except in the case of oxides, right, what has to be done is that this ns orbitals what are there, what is paired over there, should get excited to the vacant d orbital over there, vacant d orbital. If it is not going to be excited except in the case of oxides, like what happens here, there only 3 electrons and 3 orbitals will participate in the formation of bond over there, then they can only show what, +3 oxidation state. If this one also excites over there in the case of pentahalides, right, then they will show +5 oxidation state. Showing of this +5 oxidation state as we go down the group decreases, it is because of inert pair effect. We have pair of electron, right, they will show inertness towards the excitation of electrons. It is due to lanthanide contraction over there. Okay, now the reason for showing what I can say less stability towards +5 as we go down the group, the reason is that is inert pair effect. That is inert pair effect. Okay, we can simply say it as reluctant of ns orbital towards excitation to form +5 oxidation state. In the case of group 15th element is called what, inert pair effect. It is due to what, lanthanide or actinide contraction. Okay, this is all about oxidation state. These are all about what, oxidation state. In the case of nitrogen, right, all the oxidation states from +1 to +4 tends to disproportionate in acidic solution or acidic medium also we can say. Okay, what does it mean by disproportionation here? What do you mean by disproportionation here? The same substance, let us take same substance in a reaction, same substance in reaction undergoes oxidation and reduction also. Okay, the same substance in the particular reaction will undergo what? Oxidation and reduction. That is what we call it as disproportionation. Those reactions are known as what? Disproportionation reaction. Okay, from group 15th, let us take an example. Okay, let us take nitrous acid, let us take, okay, HNO2, nitrous acid. Okay, this nitrous acid undergoes disproportionation in acidic medium. Okay, it forms HNO3 and it forms NO. It also forms H2O over there. Okay, now let us take what are the oxidation states we have here. Okay, now when it comes to nitrogen, in the case of HNO2 here, nitrous acid, what do we have is that, let us calculate the oxidation number of nitrogen here. What is this? 1 plus X minus 2 is equals to 0. Oxygen is minus 2, right? Together 4, minus 4. X is equals to what? Plus 3. Nitrogen shows plus 3 oxidation state in the case of HNO2 over here. Okay, when it comes to HNO3 here, 1 plus X minus 6 is equals to 0. X is equals to plus 5. This is plus 5. When it comes to NO over here, X minus 2 is equals to 0. X is equals to what? Plus 2. Now if you see this particular reaction, right, what do we have here? We have nitrogen compound. It might be anything, okay, with plus 3 oxidation state. It forms a product which has plus 5 oxidation state, as well as it forms another product which has plus 2 oxidation state. Okay, now in this case, first case, right, where HNO3 is being formed over here, in this case oxidation state is increasing from plus 3 to plus 5. Means it is undergoing oxidation here. Okay, when it comes to this one, right, plus 3 to plus 2, right, plus 3 to plus 2 is decreasing in oxidation state, right? That's what we will call it as reduction over here. Okay, reduction. Now in this particular reaction, if you observe, right, the same nitrogen is undergoing oxidation and the same nitrogen is undergoing what? Reduction, by changing its oxidation state from plus 3 to plus 5 and plus 2 respectively over there. Okay, the same substance is undergoing what? Oxidation and reduction over there. That's what we will call this one as, this is undergoing what? Disproportionation. This type of reactions are called what? Disproportionation reaction. Now when it comes to phosphorus and the following elements as we go down the group, right, all the intermediate oxidation states, okay, what are the intermediate states? It should not be minimum oxidation state or with the maximum oxidation state. Okay, it should be in between. Okay, all intermediate oxidation state will undergo disproportionation in acidic medium and basic medium, and they will form the respective minus 3 and plus 5 oxidation state. Okay, this is all about the disproportionation of group 15th elements. Okay, and let us see the covalency of nitrogen over there. Nitrogen is restricted to a maximum covalency of 4. Why it is restricted to only 4 over there? Because it has only one s orbital and 3 p orbitals, because of which it can extend its covalency to maximum of 4 only. It cannot go beyond that one. But the remaining elements, whatever we have, like from phosphorus to bismuth, right, they can extend their valence till 6 over there. For example, we can also go with PF6. Okay, PF6. Okay, since they have vacant d orbitals, right, they can extend their covalency till 6 over there. But in the case of nitrogen, it is not possible because it has only 4 available orbitals for bonding. Orbitals for bonding. That is the reason why nitrogen is covalency is restricted to only 4 over there. Okay, and then out of all these elements of group 15, right, from nitrogen to bismuth over there, out of all these elements, right, nitrogen shows certain specific properties over there, by which, like, we cannot see these properties in the case of remaining elements in the group 15 over there. Why this one alone shows the different properties over here is that it is of smallest size, or it has smallest radius comparatively with any other elements in the group 15 over there, and it has high electronegative elements in the group 15 over there. Okay, if you consider all the elements in the periodic table, nitrogen is the third highest electronegative element in the periodic table over there. Okay, because of its small size and high electronegativity and high ionization enthalpy also. Okay, and The last one is most important, non-availability of d orbitals. Okay, because of these particular reasons, right, nitrogen shows certain anomalous properties. Okay, for example, when it comes to non-availability of d orbitals, right, we know that nitrogen and nitrogen is connected with triple bond, right? Okay, while formation of multiple bonds, right, one is sigma, remaining all are pi bonds, we knew it. Okay, during the formation of pi bonds, right, due to availability of only p orbitals over there, it can form only p pi pi bonds. Okay, it can form p pi bond over there. But when it comes to d pi p pi, right, d pi p pi, it is not possible in the case of nitrogen. It is because of what? Non-availability of d orbital. Non-availability of d orbitals. Okay, and one more thing also we can discuss over there: small size and high electronegativity. Right, nitrogen. If when it comes to nitrogen over there, nitrogen and nitrogen, if it forms like it shows a catenation. Let us assume over here. Okay, due to small size over there, what do we have here is that we have lone pair right here. We have lone pair over there. Due to small size and high electronegativity, when it forms a single bond or self linkages with another nitrogen atom over there, what happens is that there will be a repulsions between lone pairs or non-bonded electrons of the nitrogen over there. Due to this reason over there is no catenation. In the case of nitrogen, it is because of the what? Small size and high electronegativity. There will be a repulsions between non-bonded electrons of nitrogen over there. Because of this reason, we cannot expect what is this one? Catenation over there. Okay, and one more thing we have to remember over here: nitrogen is very inert at room temperature, but phosphorus is high reactive at room temperature. It is because of its high bond enthalpy. Okay, nitrogen N2 is inert at room temperature. It is because of its high bond enthalpy. Because of this reason, right, it seems like it will be very reactive at room temperature, whereas when it comes to phosphorus, it is high reactive. You know, it catches fire. To avoid this particular thing, right, it will be stored under water. Okay, next let us see the group 15th elements, right? Group 15th elements over here towards reactivity towards hydrogen, oxygen, halides and metals over there. Okay, let us see the first one here, reactivity towards hydrogen. Okay, when group 15th elements combines with hydrogen, they will form a compound which has a general formula of EH3. While formation, if energy is being released, the formed product is going to be stable. Okay, from that point of view, right, let us see the enthalpy of formation of EH3 over there. NH3, PH3, ASH3, SBH3 and BiH3 over there. Okay, only in the case of ammonia alone, we have negative formation enthalpy of formation over there, followed by all the other EH3 formation is happening like having positive enthalpy of formation. Okay, due to this particular reason, out of all NH3 is most stable and BH3 is what? Least stable. Okay, stability of EH3 decreases down the group from NH3 to BH3 over there. Okay, and reducing character, what happens? Stability is decreasing, no, but when it comes to reducing nature increases down the group. Why it is so? In the sense, see the bond strength of BiH bond and the bond strength of NH bond, if we compare, right, BiH3 can release hydrogens easily, can reduce the other substance easily, but not NH3 over there. Based on the bond strength, we can see here, this is the bond dissociation energy of the EH bond over there. As we go down the group, bond enthalpy decreases. Due to decrease in bond enthalpy, they can release the hydrogens easily comparatively with NH3 over there. That's what, as we go down the group, what happens is that the reducing character of the hydrides increases. Okay, out of all these hydrides of group 15th, right, we can take BiH3 as strong reducing agent. When it comes to NH3, we will take it as mild reducing agent. Okay, the reason we have already discussed, it is all about bond strength of EH bond over there. Okay, and let us take the basicity. Basicity in the sense, we will just discuss this one as donation of lone pair of electrons from the group 15th elements to the hydrogen over there. Okay, The donation of electrons will be easier in the case of nitrogen and hydrogen over there, followed by any other what I can say hydrates of the group 15th over there. Okay, that's what. When it comes to basicity, right, like NH3 will be the strong base over here, followed by what, any other BIH, like any other group 15th hydrides over there. That's what, as we go down the group, what happens is that basicity decreases, and we have one other important point to discuss from the particular like table over here. Okay, what is this one? Let us go with boiling and melting points right here. Let us go with melting points right now. Let us take melting points. Okay, let us take temperature here. Temperature versus EH3, let us take. Okay, whatever hydrides it might be. Okay, let us take the melting points of NH3 here. What is the melting point of NH3? Let us take it is 195 here. 195 means let us take it here. And the second one is PH3. The melting point of PH3 is 139. Means around like 140. Let us take from NH3 to PH3, melting point is decreasing, and then ASH3 it is increasing. Okay, 156 and 185. Out of all this hydrides of group 15 from NH3 to SBH3, right, NH3 has highest melting points. If you combine this one, we will get this one. Okay, this is NH3, this is PH3. Okay, this is what ASH3, this is SBH3. Okay, now what is happening is that when it comes to boiling and melting points, we have to remember one point. The melting point or boiling point most of the time is directly proportional to their molecular weight or molecular masses. Okay, means what, as we go down the group, molecular weight increases. As molecular weight increases, we can also expect increase in boiling points or melting points, right? But here we can see one exception, that is NH3 here. Though it has lowest molecular weight followed by any other hydrides over there, why it has highest melting point over there? That is one question. Let us take the another one. What we can take, let us go with boiling point over there. What do we have the first point over there? Let me take it over here for the boiling points. Okay, let us take the boiling points right here. Okay, let us take the temperature here and boiling points of group 15th hydrides over there. Okay, we have NH3 here where it has 283 boiling point kelvins, and what do we have? PH3 is 185, again decreasing, and 210 it is increasing, and 254 it is increasing, 290 it is increasing. Okay, this is NH3, this is PH3, this is ASH3, this is SPH3, BiH3. Okay, see here, as we have already discussed, okay, the melting points or boiling points in general, what happens is that they will directly proportional to the molecular weight masses over there. But when it comes to these examples, right, NH3 shows the exception in the case of melting point. This is the melting point order, this is boiling point order, right? In these two cases, what is happening here is that nitrogen is showing some exception here, but remaining all are following the general trend over there. As the molecular mass increases, melting points and boiling points are increasing over here, right? The reason for this thing is, it is due to presence of intermolecular hydrogen bonding in the case of NH3. It is due to what? Presence of what? Intermolecular hydrogen bonding. Intermolecular hydrogen bonding. Okay, hydrogen bonding. Okay, if you don't understand what is meant by hydrogen bonding, I'll leave you in the link in the card. You just go through what is it mean by hydrogen bonding over there. To form the hydrogen bonding, right, the hydrogen should be connected to more electronegative atoms such as fluorine, oxygen and nitrogen, right? In the case of NH3, hydrogen is directly connected to nitrogen over there, because of which it can form the hydrogen bonding over there. Because of this presence of intermolecular hydrogen bonding in the case of NH3 over there, in the case of melting points and boiling points, it shows exception. Only nitrogen shows the exception, remaining all will follow the general trend. As the molecular mass increases, their boiling points and melting points also increases. This is all about the reactivity of group 15th elements towards hydrogen. Okay, let us go with reactivity of group 15th elements towards oxygen here. Okay, what happens here? All these elements forms two types of oxides. Okay, one is E2O3, another one is E2O5. Okay, one is with +3 oxidation state, another one is +5 oxidation state. One is plus 3 oxidation state, another one is plus 5 oxidation state, right? Remember, two oxides will be formed. One is formula with E2O3 with plus 3 oxidation state. Other one is E2O5 with plus 5 oxidation state here, okay? The oxides in the higher oxidation states of the elements, okay, are more acidic than that of what? Lower oxidation state. If you compare the acidic nature of E2O5 and E2O3, right? E2O5 is with plus 5 oxidation state, means higher oxidation state will be more acidic. This one is more acidic. More acidic comparatively with what? E2O3 over here. And then their acidic character decreases down the group. As we go down the group, what happens? Metallic nature increases. Like oxides of metal shows what? Basic character but not acidic character, okay? Let us take oxides of group 15th elements with plus 3 oxidation state, okay? Let us take N2O3, let us take P2O3, let us take AS2O3, let us take Sb2O3 and Bi2O3. If you take oxides of group 15th elements, right? Okay, what happens? We know that nitrogen and phosphorus are non-metals, right? Non-metallic oxides are acidic in nature. That's what N2O3 and P2O3 are acidic in nature. Acidic in nature. When it comes to AS2O3 and Sp2O3, right? They are metalloids in nature, means they can react with both acids and bases over there. That's what they will form amphoteric oxides over there, okay? They will form what? Amphoteric oxides, okay? Since bismuth is metal over there, that's what it forms what? Basic oxides. Basic oxides, right? When we take this one into the aqueous medium, right? They will form the respective acids with the oxidation state. What do we have here? Plus 3. Plus 3. Okay? Then, let us go with the reactivity of 15th group elements towards halogen, okay? Here also, similar to what I can say, oxides, right? These can also form two kinds of halides. One is trihalide, second one is pentahalides, okay? Trihalides are of with the plus 5 oxidation state, plus 3 oxidation state, and EX5 with what? Plus 5 oxidation state, okay? Nitrogen does not form pentahalides. The reason for this one is, there is a question, okay? What is that question is that nitrogen shows plus 5 oxidation state but does not form pentahalides. The reason is, no, there is non-availability of no d orbitals. Okay, because of this particular reason, nitrogen doesn't form pentahalides over there. In the case of nitrogen, right, like it can only form trihalides, out of which only one trihalide is known to be more stable, that is NF3 over there, okay? If you consider these two, right, EX3 and EX5 over there, this will be with plus 3 oxidation state, this will be with plus 5 oxidation state. If you compare the nature of plus 3 and plus 5 oxidation states, halides, right, trihalides and pentahalides respectively, plus 5 oxidation state containing pentahalides are more covalent in nature. The reason for this particular nature is that according to Fajans rule, right, higher the oxidation state in positive value, right, will be having more polarizing power. The one which will have the more polarizing power will be more covalent in nature. And one more thing we have to remember when it comes to halides over here, right? Tendency to form pentahalides as we go down the group decreases, as we have already discussed in the case of oxidation states, right? Plus 5 oxidation state decreases down the group. It is because of what? Inert pair effect, okay? The same thing will be considered here also. Let us see the last one here. Reactivity towards metal over there, okay? Generally, all these group 15th elements, right, reacts with metals, forms a binary compounds where the central atom, that is group 15th element, carries minus 3 oxidation state. For example, if you take calcium, when calcium combines with nitrogen, forms what? Calcium nitride. Okay, when it combines with phosphorus, it forms what? Calcium phosphide. When sodium combines with arsenic, right, it forms sodium arsenide. When zinc combines with antimony, right, zinc antimonide. When magnesium combines with bismuth over there, right, magnesium bismuthide, okay? These kind of binary compounds will be formed with the oxidation state minus 3, right? These are the few chemical reactions of group 15th elements. In the next class, we will discuss about preparation and properties of dinitrogen, okay? Thank you for watching.